This is lesson 1-6, part 3. In this lesson, we'll learn how to write and solve inequalities involving absolute value. So here's an absolute value inequality. We will set it up like we did with the equations. So we'll have x minus 1 is less than 5. And then we'll have 2x minus 1 with a negative 5, but we don't keep it less than, we flip it over to be greater than. And then we'll solve the equation, which I'm going to do very quickly here. And I get x is less than 3 and x is greater than negative 2. And then we're going to graph that. So we start with 0 and 2 units to the left, 3 units to the right. We have a less than, so that's going to be an open circle on the 3 going left. We have a greater than, it's an open circle on the negative 2 going right. So it ends up being the shaded region between these two dots. You can try example B. Here's another example. We set it up. 2x plus 4 is greater than or equal to 6. 2x plus 4 is less than or equal to negative 6. And then we quickly solve this. And we end up with x is greater than or equal to 1. And x is less than or equal to negative 5. And then to graph that, we have 0, 1, 1, 2, 3, 4, 5. Okay, in both of these situations, the inequality is greater than or equal to or less than or equal to. So we end up coloring in the circle. Okay, and what's different here is that x is greater than 1, so it shades outward. X is less than negative 5, shades outward. So when your inequality here is a greater than, it ends up shading outside of both endpoints. And when the inequality is a less than, like it was on this page, you shade between your two endpoints, which should make sense because absolute value is distance from 0. So this is saying the absolute value of something is less than 5. So it's going to be on each side of that, but in between the two dots. And then in this case, the absolute value of something is greater than something, so it would have to be outside of the two dots. So here's an application to this. If any of you have done the Pinewood Derby cars, this is where you create the cars out of a little block of wood and then run it down a ramp and see who's can go the fastest. Well, when you do these Pinewood Derby cars, the maximum weight you can put on the car is 5 ounces. And people that have done this a lot of times, they found the ideal place to put the weight is between 0.75 inches and 1.25 inches from the back of the car. So what we want to do is write an absolute value inequality that describes that ideal spot. So I'm going to start by graphing it. So we have 0.75, 1, 1.25, and we want our weight to be between these two endpoints, so it looks like this. So we're going to write an inequality to represent that graph. To do that, I'm going to first extend my graph. So now my graph includes 0 because absolute value is distance from 0. So to write the absolute value inequality, we first want to know how far is the middle of this shaded region from 0. So it's 1 unit from 0. I start with x minus 1 with the absolute value stuff on it. From the center of the graph out to the endpoints is our distance. So we want that distance to be 0.25 from 1. So 0.25 will go here. And then because we're shading between the two endpoints, that means this is a less than, or it's not really specific here. It says about, so we could go equal or not equal. Let's just say less than 0.25. And that's the absolute value inequality that represents this situation.